The moon hangs low over black water, casting silver light across gentle swells. Lieutenant Commander Slade Cutter stands in the conning tower of USS Seahorse, eyes fixed on the dark silhouettes moving against the horizon. 4 Japanese cargo ships, heavy with oil and raw materials from the Dutch East Indies, steam in loose formation toward the home islands. No escorts, no zigzag pattern, just steady, confident progress through waters they believe are safe. Cutter's finger hovers over the firing trigger. 2 years ago, this moment would have meant nothing. 2 years ago, American torpedoes were technological jokes, weapons that ran too deep, exploded too early, or refused to explode at all. Japanese intelligence officers had catalogued every failure, every malfunction, every defective weapon, and concluded that American submarines were no serious threat. But tonight, 6 Mark 14 torpedoes leave Seahorse's tubes with a precision the Japanese never anticipated. Within 11 minutes, all 4 cargo ships are gone, swallowed by the Pacific, along with 15,000 tons of irreplaceable fuel. The Japanese had dismissed American improvements. They were about to pay for that dismissal with their entire navy. The story begins not in 1944, but 3 years earlier when Japanese confidence in their technological superiority seemed absolutely justified. On December 7, 1941, as fires consumed Battleship Row and smoke blackened Hawaiian skies, Japanese naval officers celebrated what appeared to be an impossible victory. Around conference tables in Tokyo, aboard destroyers patrolling the Pacific, inside submarine hulls lurking off American coastlines, the same conviction echoed through every conversation. American industrial might had been crippled permanently. That confidence rested on more than Pearl Harbor's destruction. It rested on a weapon that Western intelligence had dismissed as impossible, a technological achievement so advanced that American naval experts refused to believe it existed even when handed detailed specifications. The Type 93 oxygen torpedo, which Allied forces would later nickname the Long Lance, represented the pinnacle of Japanese naval engineering and a quantum leap beyond anything in Western arsenals. The intelligence arrived on May 13, 1940, delivered by a walk-in source whose identity remains classified 8 decades later. This individual, risking execution if discovered, provided the United States naval attaché in Tokyo with complete technical documentation of Japan's newest torpedo. The specifications seemed almost fantastical to Western eyes trained on conventional weapons. Range exceeding 22,000 yards at 48 knots. Operational capability extending to 33,000 yards at reduced speeds. A warhead containing 1,080 pounds of high explosive, nearly double the payload of American torpedoes. Most remarkably, a propulsion system using pure oxygen instead of compressed air, eliminating the telltale bubble trail that made conventional torpedoes visible to trained lookouts. The source provided technical drawings showing the intricate oxygen generation and storage systems. Performance data detailed exact ranges at various speed settings. Operational doctrine explained how Japanese destroyers and cruisers would deploy these weapons in night surface actions, launching massive torpedo salvos from ranges Western navies considered safely beyond threat distance. The intelligence package was comprehensive, accurate, and terrifying in its implications. The Office of Naval Intelligence evaluated the report with professional thoroughness, forwarded it to the Bureau of Ordnance for technical assessment, and received back a conclusion that would cost thousands of Allied lives. The Bureau dismissed the intelligence entirely, filing it away as unreliable information from an unverified source. The reasoning reflected prejudices that permeated Western military thinking about Asian technological capabilities in the pre-war era. Japanese engineers, Bureau analysts concluded, could not possibly have developed a torpedo more advanced than American weapons. The United States possessed the world's most sophisticated industrial base, the most advanced research institutions, the deepest pool of engineering talent. The idea that an Asian naval power could surpass American technology in any significant way contradicted fundamental assumptions about Western technological superiority. The use of pure oxygen as an oxidizer, while theoretically possible, was deemed too dangerous and too sophisticated for Japanese engineers to master safely. Pure oxygen is extraordinarily volatile, creating catastrophic explosion risks if containment systems fail. American engineers had experimented with oxygen propulsion and abandoned it as too hazardous for operational use. The report suggesting Japan had solved these problems and deployed the technology operationally was filed. Away and largely forgotten, this dismissal reflected broader contempt that shaped Western military assessments of Japanese capabilities throughout the late 1930s. Admiral Richmond Kelly Turner, who would later command amphibious forces in the Pacific and earn 4 Navy Crosses for distinguished service, testified before Congress in 1940 that Japanese pilots were inherently inferior due to supposed racial characteristics affecting their vision and spatial awareness. These racist assumptions, presented as scientific fact in official testimony, insisted that Japanese aviators lacked the night vision necessary for effective combat operations, that their technical training was inadequate compared to Western standards, that their aircraft were crude copies of Western designs built with inferior metallurgy and engineering. Army Air Corps intelligence assessments from early 1941 confidently stated that the Mitsubishi A6M-0 fighter was a derivative of obsolete American designs and would prove no match for American aircraft in combat. The Zero's combination of range, maneuverability, and firepower was dismissed as impossible given Japan's supposed technological limitations. When reports from China described Zero fighters outperforming every aircraft the Chinese Air Force possessed, American intelligence officers attributed the results to poor Chinese pilot training rather than superior Japanese equipment. These assumptions would exact a terrible price in American blood during the war's opening months when Japanese pilots flying technically superior aircraft and employing sophisticated tactical doctrine dominated the skies over the Philippines, Wake Island, and the Dutch East Indies. The cost of intelligence failure became apparent almost immediately after Pearl Harbor, measured in ships sunk and sailors drowned. 7 American heavy cruisers would be destroyed by Type 93 torpedoes during the Pacific War. USS Quincy, USS Vincennes, USS Astoria, USS Chicago, USS Northampton, USS Indianapolis, and USS Houston all fell to long-lance weapons fired from ranges Allied commanders thought safely beyond torpedo threat. 9 destroyers were sent to the bottom by these silent killers, running without bubble trails through dark Pacific waters. The fleet aircraft carrier USS Hornet, already crippled by dive bomber attacks at the Battle of Santa Cruz Islands, received her death blow from destroyer-launched Type 93 torpedoes that finished what aviation had started. Over 3,000 American sailors died as direct result of long-lance hits, drowning in oil-covered waters, burning in fuel fires, or going down with their ships in the terrible seconds after torpedo detonations tore open hulls below the waterline. In most cases, the ships believed themselves safely beyond torpedo range when weapons struck. Lookouts scanning horizons saw no enemy vessels close enough to pose threats. Captains maneuvering their ships believed they operated outside danger zones based on intelligence estimates of Japanese torpedo capabilities that were catastrophically wrong. Then long lances launched from cruisers and destroyers, 15 or even 20 miles distant, would slam into hulls and detonate with devastating effect, the massive warheads breaking keels and flooding engine rooms before damage control parties could even reach their stations. The first major encounter came at the Battle of the Java Sea on February 27, 1942. Dutch Rear Admiral Karel Doorman, commanding a scratch force of American, British, Dutch, and Australian cruisers and destroyers, led his ships out of Surabaya to intercept a Japanese invasion convoy approaching Java. The Allied force consisted of heavy cruisers HMS Exeter and USS Houston, light cruisers HNLMS De Ruyter, HNLMS Java, and HMAS Perth, and 9 destroyers representing 4 different navies with 4 different tactical doctrines and crippling language barriers hampering communication. Dorman was a competent officer thrust into an impossible situation, commanding ships that had never operated together, with crews exhausted from months of continuous retreat, facing a Japanese force that had trained together for years and operated with unified command and doctrine. The battle began at 1600, hours when Japanese and Allied forces made visual contact at extreme range. The Japanese heavy cruisers Haguro and Nachi, supported by light cruiser Naka and 14 destroyers, maneuvered to bring their torpedo batteries to bear while maintaining gun range. At 1633 hours, light cruiser Naka launched 4 Type 93 torpedoes at the almost unbelievable range of 15,000 yards, over 7 nautical miles. Her escorting destroyers followed between 1640 and 1645 hours, launching 27 more torpedoes from ranges between 13,000 and 15,000 yards. At 1652 hours, heavy cruiser Haguro added 8 more torpedoes from 22,000 yards, over 11 nautical miles, a range so extreme that Allied lookouts weren't even scanning for torpedo threats at that distance. The sea between Japanese and Allied forces filled with nearly 40 long lances running at depths of 12 feet, leaving no wakes, their oxygen propulsion systems producing no telltale bubbles. Allied lookouts and sonar operators, trained to detect torpedoes at much shorter ranges based on American and British torpedo capabilities, saw nothing until far too late. At 1713 hours, 1 Type 93 struck Dutch destroyer Kortener amidships. The half-ton warhead detonated against the destroyer's thin hull plating, the explosion breaking her back. Kortener jackknifed and sank in less than 2 minutes, taking most of her crew of 150 men with her, trapped below decks or pulled under by suction as the destroyer plunged bow first into the depths. Allied commanders, unable to comprehend torpedo attacks from such extreme ranges, concluded that submarines must be responsible. Throughout the remainder of the battle, Allied vessels maneuvered frantically to avoid what they believed were submarine-launched torpedoes, disrupting their formation and preventing coordinated attacks on the Japanese surface force. The battle raged for 7 hours as Dorman attempted repeatedly to reach the invasion transports, and Japanese surface forces maneuvered to block him. Heavy cruiser Exeter took an 8-inch shell hit that penetrated her boiler room, reducing her speed and forcing her out of line. British destroyer Electra was sunk by gunfire after making a gallant but futile torpedo attack against overwhelming odds. Dorman's force, reduced to 4 cruisers after American destroyers withdrew due to fuel and ammunition shortages, continued searching for the invasion convoy through the night, determined to prevent Japanese troops from landing on Java even if it cost every ship. At 23:25 hours, Japanese cruisers Haguro and Nachi, tracking the Allied force by radar while remaining invisible in the darkness, launched another spread of torpedoes from long range. At 2332 hours, 1 Type 93 struck light cruiser Java. The explosion ignited her forward magazines, the ammunition detonating in a catastrophic secondary blast. Java blew apart and sank almost instantly, taking 512 of her crew of 600 with her. The survivors left swimming in burning oil as their ship vanished beneath the waves. Minutes later, at 2338 hours, another long lance struck Dorman's flagship De Ruyter. The torpedo detonated against the cruiser's ammunition magazines, triggering a secondary explosion even more violent than Java's death. De Ruyter broke in half and sank within minutes, killing Rear Admiral Dorman and 345 of his crew. The Battle of the Java Sea cost the Allies 2 light cruisers, 3 destroyers, and approximately 2,300 sailors killed. Japanese losses totaled 4 transports hit by stray torpedoes from their own cruiser Mogami during confused night maneuvering, and minor damage to 1 destroyer. The invasion of Java proceeded without further interference. Allied naval power in the Dutch East Indies effectively destroyed in a single afternoon and evening of combat. More significantly, the battle demonstrated the devastating lethality of the Type 93 torpedo and the Allied inability to counter it effectively. Yet American intelligence, analyzing battle reports and interrogating survivors, refused to believe that surface ships had launched torpedoes from the ranges reported. The assessment remained that submarines were responsible, that Japanese surface torpedo capabilities were comparable to Allied weapons, that reports of extreme-range torpedo attacks were exaggerations by exhausted crews under extreme stress, rationalizing defeat. This pattern of denial would continue through subsequent disasters, each one adding to the butcher's bill, while intelligence officers clung to assumptions that felt comfortable rather than accepting evidence that demanded complete revision of tactical doctrine and strategic planning. The price of that institutional blindness would be paid in full at Savo Island 6 months later. Lieutenant Commander Frederick Warder stood in Seawolf's conning tower on December 14, 1941, just 7 days after Pearl Harbor, watching through his periscope as 8 Mark 14 torpedoes tracked toward a stationary Japanese freighter anchored off Mindanao's southern coast. The setup was perfect, the kind of attack that submarine commanders dream about. Range 3,000 yards, target anchored and unescorted. Sea calm, visibility excellent. Warder had maneuvered his boat into textbook attack position, calculating firing solutions with meticulous precision. 7 torpedoes missed entirely, passing beneath the target or running wild on erratic courses. The 8th struck the freighter squarely amidships with a dull clang that echoed through Seawolf's hull. Warder's crew heard the impact clearly through the submarine's steel plating. No explosion followed. The torpedo, its warhead packed with 643 pounds of Torpex explosive, had hit the target directly and completely failed to detonate. The freighter, its crew now fully alerted to the submarine's presence, got underway and escaped while Seawolf dove to avoid depth charge attacks that never came because the Japanese vessel had no anti-submarine weapons. Aboard, Warder's after-action report documented the failures with clinical precision, but beneath the professional language lay profound frustration. His crew had trained for years to become submarine warriors. They had taken their boat into harm's way, despite knowing that submarines suffered the highest casualty rates of any American combat arm. They had executed a perfect attack against an ideal target, and their primary weapon had completely failed them. This pattern repeated itself with numbing regularity across the Pacific throughout 1942. On December 24, 1941, Christmas Eve, Commander Tyrrell Jacobs, commanding USS Sargo, encountered 4 Japanese cargo ships steaming in loose convoy off the Indochina coast without escorts. Jacobs maneuvered into textbook attack positions, firing 3 torpedoes at each of 4 targets, 12 torpedoes total, from ranges between 1,000 and 2,000 yards. Conditions were perfect. Sea calm, visibility excellent, targets maintaining steady courses and speeds. Every torpedo either missed entirely or malfunctioned. Not a single explosion. Jacobs observed through his periscope as torpedo after torpedo passed beneath targets, or struck and failed to explode or exploded prematurely without causing damage. He fired his final attack, the last 4 torpedoes in his forward tubes, at a large cargo ship that had actually stopped and was lowering boats to investigate what was happening. All 4 torpedoes ran beneath the stationary target, passing harmlessly underneath despite perfect firing solutions. Sargo returned to Manila Bay on December 30th, with her crew completely demoralized, having expended all 24 torpedoes aboard without sinking a single ship. Jacobs filed a scathing after-action report, stating unequivocally that his torpedoes were running far deeper than their set depths, passing harmlessly beneath targets. The Bureau of Ordnance in Washington, responsible for torpedo development and production, dismissed his complaints with barely concealed contempt. The Mark 14 torpedo suffered from 3 separate catastrophic defects that masked each other and made diagnosis extraordinarily difficult. Understanding how these defects remained undetected requires understanding how the torpedo was designed, tested, and deployed under Depression-era budget constraints that made comprehensive testing impossible. The first defect was depth control. The torpedo ran 10 to 11 feet deeper than its set depth because the depth control mechanism had never been properly tested with the heavier combat warhead. When engineers increased warhead weight during final development, adding 80 pounds of additional explosive to increase lethality, they failed to recalibrate the hydrostatic depth sensor. Additionally, this sensor was poorly positioned on the torpedo's body, where water flow created pressure variations that confused the mechanism. As the torpedo accelerated to combat speed, water flowing over the hull created a pressure drop at the sensor location through Bernoulli's principle, the same aerodynamic effect that creates lift on aircraft wings. The depth mechanism, detecting this pressure drop, interpreted it as the torpedo being too shallow and responded by trimming the torpedo to run deeper. The faster the torpedo ran, the greater this effect became. Every Mark 14 fired in combat in 1941 and 1942 ran far beneath its intended depth. Torpedoes set to run at 10 feet depth, designed to strike ships at the waterline where damage would be most effective, actually ran at 20 to 25 feet depth, passing harmlessly beneath targets. A simple laboratory test immersing a non-moving torpedo in a pool of static water would not reveal this problem because there was no water flow to create the pressure effect. Dynamic tests using exercise heads with depth recorders showed the torpedo running at correct depth, but the depth measuring device in the exercise head suffered from the same placement problem and gave consistently incorrect measurements. The second defect was the Mark 6 magnetic exploder, designed to detonate when it detected the magnetic signature of a ship's steel hull overhead. In theory, this was brilliant tactical innovation. The torpedo would run beneath the target and explode under the keel, where the shock wave and gas bubble would be most effective at breaking the ship's back. In practice, the Mark 6 proved wildly unreliable across different magnetic environments. The Earth's magnetic field varies significantly with location, affected by latitude, local geology, and other factors. The Mark 6 had been tested near the Naval Torpedo Station in Newport, Rhode Island, where magnetic field strength and orientation were suitable for its operation. In combat in the Pacific, operating near Java, the Philippines, Guadalcanal, and Japan itself, magnetic field characteristics were entirely different. The Mark 6, calibrated for Newport's magnetic environment, failed catastrophically in actual combat conditions. Some torpedoes exploded prematurely, detonating 50 or 100 yards before reaching their targets when the magnetic trigger detected the target's signature at too great a range. These premature detonations did minimal damage, merely alerting targets that they were under attack and allowing evasive action. Other torpedoes passed beneath targets and failed to explode at all because magnetic field changes weren't sufficient to trigger the exploder in the actual operating environment. The Bureau of Ordnance's response to failure reports from submarine commanders represented institutional failure at its most catastrophic. The Bureau's position was that the Mark 14 torpedo was the most sophisticated, most thoroughly tested weapon in the American arsenal, and that any failures were due to operator error, not design flaws. This position would be maintained with bureaucratic obstinacy for nearly 2 years while American submarines fired thousands of defective torpedoes and Japanese merchant ships steamed safely to port. When Lieutenant Commander Eugene McKinney, commanding USS Tambor, fired 8 torpedoes at a Japanese destroyer in April 1942 from 800 yards range and heard 8 dull metallic clangs as they struck the destroyer's hull without exploding. His after-action report documented the failures in meticulous detail. The Bureau of Ordnance Response accused him of improper torpedo handling and poor maintenance practices. When Commander Warder reported similar failures from Seawolf, the Bureau suggested he needed additional training in proper torpedo maintenance procedures. The institutional resistance to admitting design flaws stemmed from multiple sources. The Mark 14 and its Mark 6 exploder represented years of development work and millions of dollars in investment during Depression-era budgets, when every expenditure faced congressional scrutiny. Admitting fundamental design flaws would require acknowledging that this investment had been wasted. Additionally, the Mark 6 magnetic exploder was classified at the highest security levels. The Bureau was extraordinarily reluctant to allow submarine commanders to examine or understand how it worked, making informed troubleshooting impossible. Most significantly, the Bureau's testing protocol had been inadequate from the beginning. Mark 14 torpedoes cost over $10,000 each in 1930s dollars, equivalent to roughly $200,000 in current purchasing power. In the depths of the Great Depression, with naval budgets slashed to the bone, the Navy was extraordinarily reluctant to spend money destroying expensive torpedoes in live-fire tests. Instead, torpedoes were tested using exercise heads, dummy warheads that could be recovered after test firings. These exercise heads were filled with water and air to approximately match the weight distribution of the combat warhead, then fired at targets or through measured ranges to verify depth control and gyroscope function. After firing, torpedoes were recovered, examined, and reused. This testing protocol seemed sensible and economical. It was also completely inadequate because the exercise head, while approximating the weight of the combat warhead, had a different weight distribution that affected the torpedo's trim and hydrodynamic characteristics in ways that wouldn't become apparent until combat use. Japanese intelligence officers monitoring American submarine radio traffic, decrypting American operational messages through partial breaks in American codes, and interrogating crews from sunken submarines, compiled detailed reports on American torpedo failures throughout. 1942. These reports reached Imperial Naval General Headquarters in Tokyo and were analyzed by intelligence staff officers who drew precisely the wrong conclusions from accurate observations. American torpedoes, they reported, were primitive weapons plagued by fundamental design flaws that appeared incapable of correction. American submariners were poorly trained and lacked the aggressive spirit necessary for effective combat operations, evidenced by their frequent patrol returns with unexpended torpedoes and minimal confirmed sinkings. The vaunted American industrial capacity was producing weapons that didn't work, ships that were inferior to Japanese vessels, equipment that broke down under combat conditions. This assessment, based on accurate observation of American failures but fundamentally wrong in its interpretation of what those failures meant, shaped strategic decisions about resource allocation that would prove catastrophic. Japanese merchant captains began reporting American torpedoes lodged unexploded in their hulls, while their ships limped safely into port for repairs. The torpedoes were carefully removed by Japanese ordnance personnel, who examined them with professional interest and growing confidence. These reports reinforced Japanese confidence that the American submarine threat was manageable, that convoy protection resources could be allocated elsewhere, that the merchant fleet could operate with minimal escort and still maintain the logistics pipeline that fed Japan's war economy. This confidence shaped strategic decisions about shipbuilding priorities and anti-submarine warfare doctrine that would prove irreversible once American torpedoes began functioning properly. Resources that might have gone to building escort vessels, developing effective sonar and radar, training anti-submarine warfare crews, instead went to battleships and fleet carriers for the decisive battle that Japanese naval doctrine anticipated. The assumption that American submarines were toothless would persist until late 1943. by which time it would be far too late to implement the convoy protection and anti-submarine measures that might have preserved Japan's merchant marine. The breaking point came in June and July 1943 through two incidents that finally forced the Bureau of Ordnance to acknowledge reality despite institutional resistance. On June 10, 1943, USS Trigger, commanded by Commander Roy Benson, encountered the fleet aircraft carrier Hyo, one of Japan's most valuable capital ships. Benson executed a textbook approach, maneuvering into perfect attack position at 100 yards range, firing 6 torpedoes in a carefully calculated spread designed to ensure multiple hits regardless of target evasive maneuvers. 2 torpedoes missed due to Hyo's emergency turn. One exploded prematurely 80 yards short of the target. The underwater detonation visible through Trigger's periscope but causing no damage. One was a dud, striking Hyo's hull and failing to explode. 2 torpedoes hit and detonated properly, causing moderate damage that reduced Hyo's speed and started fires. Hyo, protected by destroyer escorts that immediately began depth charge attacks, limped away for repairs instead of sinking. The second incident proved even more definitive. On July 24, 1943, Lieutenant Commander Lawson Daspit, commanding USS Tenosa, spotted the 19th 250-ton whale factory ship Tonin Maru No. 3, alone and unescorted south of Truk. Daspit maneuvered into attack, position at 4,000 yards, and fired 4 torpedoes, observing 2 hits that stopped the ship dead in the water. He immediately fired 2 more torpedoes, both hitting. 6 torpedo hits should have been more than sufficient to sink any merchant vessel. Tonin Maru No. 3 remained afloat, dead in the water but refusing to sink. With no enemy anti-submarine forces in sight, Daspit had time for careful observation. He maneuvered Tenosa into textbook-perfect position, 875 yards directly, abeam of the target where missing was impossible, and fired 9 more torpedoes, observing each one carefully through his periscope, despite Japanese machine gun fire from the target ship. All 9 hit the stationary target squarely at the optimal 90-degree angle. None exploded. Daspit heard the dull thuds of impact through Tenosa's hull. Not a single torpedo detonated. Rear Admiral Charles Lockwood, Commander Submarine's Pacific Fleet since January 1943, recognized that Daspit's experience represented a controlled experiment conducted under combat conditions. Lockwood was himself an experienced submariner who had commanded submarines before moving to senior positions. He had listened to 2 years of his submarine commanders reporting torpedo failures, while the Bureau of Ordnance blamed every failure on operator error. He now had proof, documented in Daspit's patrol report with photographs and detailed observations, that the contact exploder was fundamentally defective. Lockwood ordered immediate testing at Pearl Harbor. His staff constructed a testing range where dummy warheads could be dropped from a pier crane onto steel plates positioned at various angles to simulate torpedo impacts. The tests revealed that the firing pin mechanism bound and jammed at high impact velocities, particularly at 90-degree impact angles. The heavier the firing pin and the stiffer the deceleration, the more likely the binding became. Direct 90-degree hits, the supposedly perfect shots that submarine commanders were trained to take, generated such sudden deceleration that the firing pin couldn't move fast enough to strike the detonator cap. The solution came from examining Japanese aircraft wreckage at Pearl Harbor. Engineers discovered that Japanese propeller blades used lightweight aluminum alloy rather than steel. If the firing pin were made from lightweight aluminum instead of steel, it would have less inertia during deceleration and would be less likely to bind. Tests confirmed the theory. By September 1943, 21 months after Pearl Harbor, modified torpedoes with aluminum firing pins began reaching submarines at Pearl Harbor and Fremantle. Japanese naval planners observing early American submarine operations through 1942 and early 1943 had concluded that the submarine threat was manageable based on statistical analysis that appeared sound. American submarines were achieving roughly 3% of their claimed sinkings when Japanese records were compared against American patrol reports. This massive overclaiming suggested either deliberate dishonesty or fundamental incompetence in attack execution and damage assessment. The merchant fleet carrying raw materials from conquered territories to Japan and carrying finished military goods from Japan to forward bases operated with minimal escort under the assumption that American submarines weren't effective enough to pose existential threat to Japanese maritime logistics. Destroyer escorts and patrol craft focused on protecting battleships and carriers rather than merchant convoys. Anti-submarine warfare doctrine emphasized protecting high-value military targets rather than the unglamorous cargo vessels that sustained the war economy. This assessment proved catastrophically wrong once American torpedoes began working reliably in late 1943. The transformation in American submarine effectiveness represented one of the most dramatic capability shifts in naval warfare history. Submarine commanders who had learned their trade in the school of hard experience, who had survived 2 years of combat despite defective weapons, now possessed torpedoes that actually worked. The effect on Japanese shipping was immediate and devastating. The transformation began quietly in the fall of 1943 as modified Mark 14 torpedoes with corrected depth control, deactivated magnetic exploders, and redesigned contact exploders began reaching forward submarine bases at Pearl Harbor, Fremantle, and Brisbane. Submarine commanders, burned by 2 years of weapon failures, approached the modified torpedoes with deep skepticism. The Bureau of Ordnance had assured them repeatedly that previous torpedoes worked perfectly, and that failures were due to operator error. Now the Bureau admitted there had been problems, but insisted those problems were fixed. Submarine captains would believe it when they saw results. E.S. Wahoo, commanded by Commander Dudley Morton, departed Pearl Harbor on her 4th war patrol in August 1943, carrying the first batch of fully corrected Mark 14 torpedoes. Morton was among the most aggressive submarine commanders in the Pacific, a cigar-chomping warrior who attacked relentlessly despite weapon failures that would have discouraged less determined officers. On October 5, 1943, Wahoo encountered a 4-ship convoy in the Ali, Perusa Strait between Sakhalin and Hokkaido. Morton attacked immediately. Despite the convoy's close proximity to Japanese home waters where air patrols were heavy and anti-submarine forces were concentrated, he fired 6 torpedoes at 2 cargo ships from 1,800 yards range. All 6 torpedoes ran true, struck their targets, and exploded with devastating effect. Both cargo ships, totaling over 8,000 tons, sank within minutes. Morton reloaded his tubes and attacked the remaining 2 ships, firing 4 more torpedoes. 3 hit and exploded properly, sending a 6,000-ton transport to the bottom. For the first time in the war, a submarine commander had fired torpedoes and achieved results matching what the weapons were designed to accomplish. Morton's after-action report expressed cautious optimism that perhaps the torpedo problems had finally been resolved. That optimism proved premature for Morton personally. Wahoo was lost with all hands on her return transit through La Perouse Strait, likely sunk by Japanese aircraft. But his patrol demonstrated that when Mark 14 torpedoes functioned as designed, American submarines were devastatingly effective. USS Harder, commanded by Commander Samuel Dealey, proved the point even more dramatically during her 5th war. Patrolled in June 1944, Dealey was an aggressive tactician who had earned Navy crosses on previous patrols despite torpedo problems. Operating in the Sibuyan Sea east of the Philippines, Harder encountered Japanese destroyers screening a convoy on June 6, 1944. Rather than evading the destroyers to reach the merchant ships, Dealey decided to sink the escorts first, demonstrating aggressive tactics that earlier would have been suicidal given torpedo unreliability. He maneuvered harder directly into the path of destroyer Minazuki, letting the enemy vessel come to him rather than maneuvering for optimal firing position. At 100 yards range, Dealey fired 3 torpedoes down the throat, aiming directly at the approaching destroyer. 2 torpedoes struck Minazuki bow on, the explosions breaking her back. Minazuki sank in less than 3 minutes, her crew having no time to launch depth charges or radio Harder's position. 20 hours later, Dealey encountered another destroyer, Hayanami, searching for Minazuki. He repeated the tactic, firing 4 torpedoes at the approaching destroyer from 100 yards range. 3 torpedoes hit, sending Hayanami to the bottom in 4 minutes. On June 8th, Dealey encountered 3 destroyers in formation, all searching for the submarine that had sunk 2 of their companions. He selected the lead destroyer, Tanakaze, and fired 4 torpedoes at 200 yards range. 3 struck home, breaking Tanakaze in half. She sank in 2 minutes. In 3 days, Harder had sunk 3 Japanese destroyers using tactics that would have been impossible with unreliable torpedoes. Each attack required perfect fire control and absolute confidence that torpedoes would function as designed. Dealey's success demonstrated that American submarines with working weapons could dominate even heavily defended waters. Japanese naval commanders, accustomed to submarines being relatively ineffective nuisances, suddenly faced a threat that could destroy escort vessels with impunity. USS Flasher, commanded by Commander Rubin, Whitaker achieved perhaps the single most successful submarine patrol of the entire war during her 4th war patrol from September to December 1944, operating in the South China Sea. Along convoy routes between Singapore and Japan, Flasher intercepted Japanese shipping carrying critical oil and raw materials. On December 4, 1944, Whitaker encountered a tanker convoy escorted by destroyers and patrol craft. He maneuvered Flasher into attack position despite heavy escort presence, demonstrating the aggressive tactics that reliable torpedoes made possible. At 100 yards range, Whitaker fired 6 torpedoes at 3 tankers steaming in line. All 6 torpedoes functioned perfectly, each finding its target and detonating with full force. The tankers Hako Maru, Otawasan Maru, and Omurosan Maru, carrying hundreds of thousands of gallons of fuel oil from the Dutch East Indies to Japan, exploded in rapid succession. The 3 ships, totaling 28,000 tons, sank in less than 20 minutes, sending their irreplaceable cargo to the ocean floor. Whitaker wasn't finished. On December 21, 1944, Flasher intercepted another convoy east of Indochina. Whitaker attacked at dawn, firing 6 torpedoes at 2 tankers. 4 torpedoes hit, sinking the 10,000-ton tanker Kikusui Maru and damaging the transport Aratama Maru so severely she had to be beached. Total tonnage sunk on Flasher's 4th patrol exceeded 45,000 tons, with additional ships damaged. Whitaker's patrol demonstrated the cumulative effect of reliable weapons in skilled hands, not just individual sinkings, but sustained pressure that Japanese logistics couldn't withstand. The statistical transformation tells the story with brutal clarity. In 1942, American submarines fired 1,242 torpedoes and claimed 201 ships sunk totaling 1.3 million tons. Post-war analysis of Japanese records revealed actual results, where 109 ships sunk totaling 417,000 tons, barely 32% of claimed tonnage. The torpedo failures weren't just reducing effectiveness, they were creating a false picture of American submarine capability that shaped Japanese strategic assumptions. In 1943, as torpedo problems were gradually corrected through the year, submarines fired 3,137 torpedoes and sank 284 ships, totaling 1,349,000 tons, roughly triple the previous year's results, from less than triple the number of torpedoes expended. By 1944, with fully functional Mark 14 torpedoes, Submarines fired 6,092 torpedoes and sank 492 ships, totaling 2,388 tons. The effectiveness improvement was roughly tenfold once torpedoes began functioning as designed. Japanese naval intelligence, monitoring American submarine radio traffic, and analyzing shipping loss reports, initially dismissed the increasing losses as statistical anomalies or temporary operational set retry decontinue edit. Japanese naval intelligence, monitoring American submarine radio traffic and analyzing shipping loss reports, initially dismissed the increasing losses as statistical anomalies or temporary operational setbacks. The assessment that American submarines were technologically inferior had become institutional dogma, resistant to revision even when evidence demanded it. Intelligence officers who had spent 2 years documenting American torpedo failures found it psychologically difficult to accept that those failures had been corrected. Reports from convoy captains describing perfect torpedo attacks, weapons that ran straight and true, explosions that broke ships' backs with single hits, were initially attributed to coincidence or exaggeration. The transformation had happened so quietly, with no American announcements, no propaganda broadcasts, no intelligence indicators that would normally accompany major weapons improvements. Modified Mark 14 torpedoes simply appeared in forward areas and began working, with no fanfare and no warning to Japanese forces. By early 1944, the statistical evidence became impossible to ignore. Shipping losses were accelerating month by month. Tankers carrying oil from the Dutch East Indies were being sunk faster than they could complete round trips. Cargo ships bringing raw materials to Japan were going to the bottom with their holds full. Food imports were declining precipitously. Most alarmingly, the pattern of losses indicated American submarines were operating with intelligence about convoy routes and schedules that should have been impossible to obtain. The reality was that American code-breaking operations, particularly the penetration of Japanese naval codes through the MAGIC program, provided submarine commanders with precise information about convoy departure times, routes, speeds, and cargo manifests. Combined with functioning torpedoes, this intelligence allowed submarines to position themselves along convoy routes and execute attacks with devastating precision. Japanese convoys' sailing routes they believed were secret found American submarines waiting in ambush with weapons that actually worked. USS Tang, commanded by Commander Richard O'Kane, exemplified the deadly combination of intelligence, tactics, and reliable weapons. O'Kane had served as executive officer aboard Wahoo under Dudley Morton, learning aggressive submarine warfare from one of its masters. Given command of Tang in October 1943, O'Kane applied those lessons with innovative tactics and absolute confidence in his torpedoes. On Tang's third war patrol in June 1944, O'Kane received intelligence about a convoy departing Nagasaki for Dairen, Manchuria. The convoy consisted of 6 cargo ships and 4 escorts, carrying military supplies and equipment for Japanese forces in China. Tang positioned herself along the expected route in the East China Sea, waiting in ambush. On June 24, 1944, the convoy appeared exactly where intelligence predicted, steaming in formation with minimal zigzag pattern. O'Kane attacked at dusk, firing 6 torpedoes at 3 cargo ships from 1,500 yards range. All 6 torpedoes ran true and exploded on impact. 3 ships, तमाहीमे मरू, तीरे ट्राइडीबस, अब एंडिंग बना के 2 बोट हो गए हैं. यहाँ से एंड कर दो, स्क्रिप्ट ये वाली एडिट. The numbers tell a story of systematic destruction that no navy in history had ever endured. By war's end, American submarines had sunk 1,278 Japanese merchant vessels, totaling 5,053,491 tons, representing 54.6% of all Japanese shipping losses from all causes. More critically, they had sunk 201 naval vessels. including the aircraft carrier Shinano, the largest carrier ever built at $72,000, tons displacement, and the largest warship ever sunk by a submarine. Kaifu toll on Japan's economy was catastrophic and fundamentally altered the strategic balance in the Pacific. Japan was an island nation utterly dependent on seaborne logistics. Raw materials from conquered territories in Southeast Asia, China, and the Dutch East Indies had to be shipped to Japan for processing. Finished military equipment had to be shipped from Japan to forward bases and combat zones. Food imports were essential to feed the population. Oil from the Dutch East Indies was critical to every aspect of the war economy and military operations. By January 1945, the Japanese merchant fleet had been reduced to barely a quarter of its December 1941 strength. Tankers carrying oil from the East Indies were being sunk faster than they could complete round trips. Cargo ships bringing raw materials were going to the bottom with their holds full. Food imports had declined to the point that rationing in Japan approached starvation levels. The industrial consequences rippled through every aspect of Japan's war effort. Oil refineries on the home islands shut down for lack of crude from the East Indies. Japan's petroleum production, which had never been sufficient for military needs even with imports from the Dutch East Indies and Borneo, collapsed to negligible levels. Steel mills closed for lack of iron ore and coking coal. Aircraft factories stopped producing for lack of aluminum, which had to be imported since Japan had virtually no domestic aluminum production. Training programs for pilots and sailors ground to a halt for lack of fuel. Naval vessels sat pierside or swung at anchor for lack of oil. The combined fleet, once the third largest navy in the world, and a force that had defeated the Russian Navy at Tsushima and dominated the Western Pacific in 1942, was reduced to immobility by lack of fuel for its ships. Army divisions in China, Southeast Asia, and the Pacific Islands withered from lack of supplies and reinforcements. Ammunition, replacement weapons, medical supplies, food, all had to be shipped from Japan, and increasingly, those ships never arrived. Troops on isolated garrisons went months without resupply as submarines sank the freighters that were their lifeline. Battle casualties couldn't be replaced as troop ships carrying reinforcements were torpedoed and sunk. The Japanese army, which had conquered vast territories and defeated Chinese, British, Dutch, and American forces in the opening months of the war, found itself slowly starving in its fortified positions because the logistics system that sustained it was being destroyed by American submarines. The home islands faced potential starvation as food imports ceased. Japan had never been self-sufficient in food production, relying on imports from Korea, Formosa, and Southeast Asia to feed its population. By 1945, those imports had been reduced to a trickle by submarine attacks on cargo ships. Urban populations in Tokyo, Osaka, Kobe, and Nagoya faced increasing hunger as rice rations were cut repeatedly. Black markets flourished as desperate civilians paid exorbitant prices for food. Japanese attempts to counter the submarine threat came too late, and with insufficient resources. By the time Japanese naval planners recognized the true magnitude of the submarine threat in late 1943, American submarines had already sunk hundreds of ships and crippled critical supply lines. The resources needed to build effective convoy escort forces, destroyers, destroyer escorts, patrol craft, sonar equipment, depth charges, trained anti-submarine warfare crews had been allocated to battleships and fleet carriers for the decisive surface. Battle that never came. Japan began a crash program to build escort vessels in 1944, but construction lagged far behind losses. The Matsu-class destroyers, simplified designs optimized for anti-submarine warfare and mass production, began entering service in spring 1944. But by then, American submarines controlled vast areas of the Pacific with near impunity. The few escort vessels available were spread impossibly thin across convoy routes stretching thousands of miles from Singapore to Japan. From the Dutch East Indies to the Philippines, from Formosa to the home islands. Japanese anti-submarine tactics remained primitive compared to Allied doctrine developed in the Atlantic. Sonar equipment was inferior and less reliable. Depth charges were less effective. Tactical coordination between escort vessels was hampered by poor communications equipment and inadequate training. Most critically, Japanese anti-submarine doctrine had never prioritized protecting merchant shipping. The focus remained on protecting naval task forces, leaving cargo convoys with minimal protection even as losses mounted to unsustainable levels. American submarine losses, while significant in human terms, were remarkably light given the aggressive tactics employed. 52 American submarines were lost during the Pacific War, taking 3,505 officers and men with them, the highest casualty rate of any American combat service, with roughly 22% of submariners killed in action. But this loss rate paled compared to the destruction submarines inflicted. The exchange ratio was roughly 50 Japanese ships sunk for every American submarine lost, a level of effectiveness unprecedented in naval warfare. American strategic bombing, which received enormous attention in popular accounts and post-war assessments, was actually secondary to the submarine blockade in destroying Japan's ability to wage war. The Army Air Force's firebombing campaign against Japanese cities, while devastating to civilian populations and psychologically traumatic, had limited immediate impact on Japan's war economy because that economy had already been crippled by lack of raw materials. Factories couldn't operate without steel, aluminum, coal, and oil, regardless of whether they were being bombed. The atomic bombs dropped on Hiroshima and Nagasaki on August 6 and 9, 1945, provided the Japanese government with a face-saving reason to surrender. But Japan was already defeated economically and militarily by that point. The nation simply couldn't continue fighting regardless of battlefield outcomes, because the economic foundation of its war effort had been destroyed by submarines. The final irony involves the Type 93 Long-Lance torpedo, the weapon that had terrified Allied navies in 1942 and 1943 and that Japanese intelligence had cited as evidence of technological superiority. By 1944, as American forces developed countermeasures and tactical doctrine to defeat it, the Long-Lance became increasingly irrelevant to the war's outcome. Radar warning systems gave American ships advanced notice of approaching Japanese surface forces. Better damage control techniques helped ships survive torpedo hits. Most importantly, increasingly aggressive. American surface forces, supported by overwhelming air power, sank Japanese torpedo-launching platforms faster than Japan could replace them. The weapon that should have been Japan's decisive advantage in surface combat became a sideshow as American submarines systematically destroyed the merchant fleet that kept the Japanese war machine operating. Japanese destroyers and cruisers designed to deliver devastating torpedo attacks found themselves relegated to escort duty, protecting what remained of the merchant fleet, a role for which they were poorly suited and which they performed inadequately. The story of Japanese dismissal of American torpedo improvements stands as one of history's clearest examples of how intelligence failures compound into strategic catastrophe. Japanese naval intelligence officers, confronted with accurate evidence of spectacular American torpedo failures in 1941 and 1942, drew conclusions that seemed logical based on available evidence. American weapons were fundamentally flawed. American submariners were poorly trained. American industrial capacity was producing inferior equipment. This assessment, while accurate in describing the immediate situation, was catastrophically wrong in its interpretation of what those failures meant for the future. Japanese analysts failed to understand that American failures were temporary technical problems that American engineering expertise and industrial capacity would eventually solve, not permanent indicators of fundamental inferiority. That failure of imagination and assessment shaped resource allocation, decisions that prioritized decisive battle doctrine over convoy. protection, and anti-submarine warfare, when American engineers systematically identified and corrected every Mark 14 torpedo defect between mid-1942 and September 1943. Japanese intelligence agencies were slow to recognize the transformation and even slower to convince operational commanders to adjust strategy and tactics accordingly. By the time Japanese naval planners understood the true magnitude of the submarine threat, it was too late. The ships had already been sunk. The merchant marine had been destroyed. The economy had been strangled beyond recovery. The mathematics of naval warfare are brutally simple. An island nation dependent on seaborne logistics cannot survive when its merchant fleet is being destroyed faster than it can be replaced. Japan's situation by 1945 was mathematically hopeless, regardless of battlefield courage or tactical skill. Without oil, steel, aluminum, and food, modern industrial warfare becomes impossible. American submarines, operating with corrected torpedoes, excellent intelligence from code-breaking, and aggressive commanders who had learned their trade through bitter experience, had reduced Japan's merchant capacity to levels that made continued resistance futile. Victory in the Pacific. War was determined not by the spectacular carrier battles at Midway and the Philippine Sea that captured imaginations and dominated headlines, but by the grinding attrition of submarine warfare that destroyed Japan's ability to sustain combat operations. The weapon Japanese intelligence had mocked as evidence of American incompetence became the instrument of Japanese defeat. The silent service that had struggled through 2 years of defective weapons became the force that strangled an empire. Wars are won not just by tactical brilliance or operational excellence, but by industrial capacity, engineering competence, and the ability to learn from failures and implement solutions faster than enemies can adapt. American submariners paid a terrible price learning how to fight with defective weapons. Japanese merchant sailors paid an even higher price for their navy's intelligence failure, and Japan's empire drowned in the Pacific, sunk not by a single decisive battle, but by the cumulative weight of 1,000 convoy attacks that severed the arteries feeding the war machine. The lesson echoes across history. Never dismiss an enemy's capacity for improvement. Never assume early failures indicate permanent weakness. And never underestimate the consequences of being wrong about an enemy's technological capabilities. Japan's navy didn't sink in glorious battle. It was strangled slowly, methodically, and mathematically by submarines their intelligence services had dismissed as incompetent, using torpedoes their analysts had mocked as defective, proving that in war, the most dangerous assumption is that your enemy cannot learn from their mistakes.